Can you hear me? Is it working? This is the weirdest thing. I have no idea if anybody can hear me or not, but I think I hear an echo.
I don't think you need a microphone.
Yeah, you're coming out of the speaker. Yeah, but
For the recording.
Yeah, it's for the stream. It's like I'm on the web, the net, the interweb.
All right, we're going to start the stream. All right, go ahead.
All right, so I'm just going to go ahead and start off cold then. Some know me, some don't. But I'm Terry Steen, and I got really wrapped up in the Microworks assembler because I wanted a new assembler, and I wanted to be like the Microworks because that was my favorite when I was growing up. And I like a lot of the stuff that's out there, and I've used a lot of different things, but I decided I wanted to have the Microworks. So for some bizarre reason, I decided that I was going to disassemble the whole thing and make it so that I could create it again. And this is the first part of it. So I do have the Microworks editor unraveled and the Microworks assembler unraveled, and I have a flash drive if anybody, and it's pretty. So if anybody's interested in the material that goes beyond what we're going to talk about today, by my booth, and even if you don't want to buy it, I got a desk copy sitting there. You guys can pull up a chair and read for hours. I don't care. So I just want to share. But so basically, the deep dive can go as deep as you guys want, and it can stay as surface as you want. But the whole thing is, how would you do a full screen editor, and how would you do something that I call an extended screen editor? Because a full screen editor to me is just you're moving around on the screen and you're editing what's on the screen. To me, an extended screen editor would be you page up and scroll through things. So that's kind of a terminology thing, which the first thing I did was do some definitions. And I'm going to do my best not to just read slides, because I think that's annoying as hell. So, but the definitions are basically based on when the Microworks editor that I'm using came out. It was all based on CoCo 1. I think CoCo 2 was out. And you're not going to find CoCo 3 stuff. All the RAM or ROM ports and everything like that it called, they're all calling to the basic ROM or to the disk ROM using the published things from Radio Shack. So there's not a whole lot of we recreated these routines or something like that. The memory, you've got the full 64K, and the only reason why I reference 64K is because you can call the basic ROM for different things. The original editor was made to operate in the 32K RAM environment, but it does address outside of that. The screen is the standard 6847 screen, text screen that you came up with on your computer. They don't use any high res, but you can, if you were to do a full screen editor, there's no reason you can't use another screen. So you could use a high res screen, you could use a redefined screen in the CoCo 3 or something like that. So this can be extended out to other things. But cursor position, left, right, up, down, and based on the screen width, the left, right, up, down, multiply the position horizontally or vertically by the screen width, add it to the position horizontally, and that'll give you an offset from the top corner. Let's see, cursor controls, typical up, down, left, right. Like I said, nothing unusual there. And when I talk about line editing, the line that you're on would be one row of the text screen. If you look at Basic, when you do edit, it pulls the entire line of Basic out and lets you edit inside of that. The Microworks editor lets you do that too. They have a longer than 32 character wide editing capacity, but we'll see that a little bit later. But the big thing is, you know, when I talk about line editing, I'm talking about just on one row of the screen. And like I said earlier, full screen, up, down, left, right to the borders. And then extended would be if you're scrolling off and scrolling in. And I'm nervous, so if you guys say, relax, calm down. Okay. And yeah, on here I'm talking about row of text being 32 characters wide. One nice thing about that is it's based in a binary numbering system. So, you know, you can say every 20 characters you have a new row. So you can actually find the row easily, or you can say, I'm going to go to the first character of that row by truncating off the bottom bits, or I'm going to go to the end by ORing in all one bits. So there's that kind of nice feature for when you're taking control of where the cursor is horizontally. Everybody's seen the standard CoCo text screen. You know, from the time you turn it on, the first time to today, you've all seen it. And I discussed the cursor offset formula. And like I said, it looks just like in the CoCo book. So if you look at the grid that I've got there, though, you know, I start off with 0, and I start off with 0, and that's just because when you're doing machine language and binary math and everything, you got to start at 0. So some textbooks will show it at 1s just because that's the first column. I'll refer to stuff when I'm writing things out as row 1, column 1, but what I really mean is 0, 0, because that's where it's actually at. But nobody wants to read row 0, column 0. But oh yeah, I got that on the bottom of the screen there, just for preference. And anybody can do it the way they want. And as examples, like I said, I got 0, 0. And down here, you take 0, 0, do the row 0 times 20 plus 0, you get 0. And then this guy here, I've got an example where it's row 4, column 2, and I run through the math, which I can't see over there. Comes out to 0, 8, 4. And I got 2 more. The very last one on the screen, when you get down to the far left or far right hand side of the screen, that one's the very last byte of the screen, and that one's the 1FF. So you're at the very last byte of the screen memory. For getting information to scroll up or scroll down, you've got destructive scrolling, which is the first thing that people typically do, and this is what the Radio Shack Basic is. So you'll say, okay, there's the top row, it's just going to X out. So everybody is going to move up. So you're going to start here at the top, and you're going to work your way across that row, grabbing the previous row, slamming it up to where you are, all the way across. You'll drop down, continue going through, doing the same thing. When you get down to the bottom here, this row would have nothing left to pull from. So that one is your new blank row. So instead of pulling from someplace else in a destructive, you just go ahead and make that all spaces. So there's your new row of text. And that's what Basic does. So you type, you get down, the screen scrolls, and you got nothing at the bottom. You're starting over from 0. Let's see. Yeah, and this is just to give you information about how it's done. The variables on here is the actual variables from the Microworks disassembly that I did, where you got the screen width, the first row of the screen, and the last row of the screen. So you start at the top, you go and you pull from one screen width down, up, and you go all the way down until you hit the first row of the screen at the bottom. And the chunk of code there, that's actually a piece of code from the book, and it's basically doing what I was talking about. So you get the screen width is your offset from your X location, pick it up from that location, drop it in the current location, move 2 bytes over, and just repeat until you get to the bottom of the screen. And this is really just an all-purpose routine. So if you say, I want to scroll just the bottom half of the screen, you can jump in any place you want and say, I want this to come up, and cut it off at that point. And they'll use this in a few different places where they jump in and they'll scroll the screen at the bottom so that they can say, okay, I want to copy a block of text. Well, I'm going to keep this block up here, and I'm just going to scroll the bottom of the screen. And then when I get done, I can go ahead and release that, and it becomes part of the text now. So that's the only reason why I'm really showing this in the code form, is so you can see it's pretty generic. It's not meant to be something that's like, okay, when you scroll the screen, this is what you have to do, and you have to have this point in memory. No, they just grab it with the X pointer, and you just go ahead and run with it wherever the X pointer is at. And typically it's always going to be at the top of the screen unless there's something going on, like a special function like what I was talking about with block moving or something like that. If this gets too dry, just say so. And this is the same thing, except this is scrolling down. This is going to get destroyed at the bottom in row 15. And you do the same thing where you start off at the bottom row, you grab one up instead of one down, drop it down there, and just keep working your way across. Or actually, from that end over here, and you keep swiping from right to left. Then when you get to the top, this row is green because you don't know what's up there, and you're not wanting to use something that you haven't stored. You just go ahead and blank it off with spaces. So now we've got a way to scroll up and destroy, and we got a way to scroll down and destroy. So if you've got a whole bunch of stuff on the screen, you can move it up and down until you just delete it all, and you can type in stuff and add stuff to it so you can recreate things. But you haven't done anything to let you scroll information off or onto the screen. And I'm sorry, I should kind of stop. Does anybody need any more explanation on this? Because I don't know if everybody's up on relocating data and memory and stuff like that. Okay, so just like the other one, pretty much the same parameters, except now the routine is, like I said, it's the opposite, where you're loading, moving backwards, and then you're storing where you're at in a row below, and then you compare to the top instead of comparing to the bottom. So these are pretty much negatives of each other. This routine and the other one, they're negatives as far as which way the program's going, which way it's storing data, and where it's going to start, where it's going to stop. So they're essentially the same function except different places. And like I said there, scroll text screen down at X. So wherever X is pointing to, that's where it's going to scroll. And the non-destructive, it's the same thing, except now we have a little place that I called the stack up here. So anything that you pull up and it gets up to the top, this top row would drop off to the stack. So you've got a 32-bit wide or 32-byte wide area. You've pulled the information up, stored it on that stack location, and you can use that again later on if you want to. This is just showing it as a one row of text. You can have as many rows of text as you want up there, but now you have to worry about stack control, how you're going to move that stack around. And we'll talk about that later on. But you're still blanking out the bottom of the screen because we don't have anything for the scroll up that brings anything in for it. And this is the non-destructive scrolling routine. And just like before, it's almost identical, except the first thing you do is you save the line of text off the top. So you save that line of text off in the stack, and now you can scroll destructively because you've saved that. You don't have to worry about where it's at or what you're going to do with it after this because it's already done. So you've got the same exact routine after you do a preservation. And for scroll down, it's basically the same thing. I left the stack at the top because I was lazy, but you're pulling all the way down. The first thing you do is you preserve the 15th row at the bottom, because you're going to pull all those down and you're going to blank that off at the top, which, like I said, the routine is almost exactly the same as the other one. This right here is the destructive scroll. This is the one where it saves and resets the pointer, and then it goes right down into the destructive scroll. I kind of wanted to talk about basic controls, mostly so that everybody knew what I was talking about. It's like I talked about earlier. You got up, down, left, right, and then you got a modifier where you can shift. So if you're going up, you're just moving up one row, but if you shift and you hit the up, you're going to go all the way to the top. Shift, hit down, you're going to go all the way to the bottom. Shift to the right, you're going to go all the way to the right-hand row. Shift to the left, you're going to go all the way to the left row. And when you go to the right-hand side, that's where I was talking about ordering in 1FF to get the right column. And if you shift to the other side, you and 1E0, and that'll take you all the way to the left-hand side. And the other controls that the Microware uses is enter. If you're on a line and you hit enter, it'll take you down to the next line to the end of the text. So that way you can just basically tab out to the end by hitting enter anytime you want to. And spacebar on their controls, it just looks to the next place on the row of text, finds a space, so it'll skip over words. So if you have big long word, big long section of code, and you hit space, it'll take you out to the next part. So if you're writing opcodes and you're like, okay, I want to get right to the comments, hit space a couple of times and you're out to the comment side. So that's just a convenience that they use, and that's just their preference. It's not like that's a rule that you have to use for every editor. So when you store stuff and you pull stuff, this is kind of a visual representation of how the stack works. So if you've got your CoCoText screen and you scroll up, it's going to go into the top row. If you scroll down, it's going to come off of the top row. And if you scroll down, it's going to, where am I at here? Pull the stack, push the stack. I probably should have labeled these differently. So if you're scrolling up, these will come off of the stack. If you're scrolling down, they'll go onto the stack. And it's kind of like you've got two buckets, and when you scroll the screen, it'll feed it into one bucket as you scroll up, and it'll pull out of the other bucket to feed in the bottom. And when you scroll down, it pulls off the bottom of the screen into the other bucket over here, but it pulls off of the other bucket on this side. So you're basically balancing between these two areas that are storing text to keep it on your screen. So if you want to make something, and this could apply to video games like the guy back there with the Spy Hunter that's on display, which I recommend you go look at, it's constantly coming in and it's constantly going off. And then if you were doing it the other way, it would constantly come in at the top and constantly go off at the bottom. And the only way to really manage that kind of structure is just to have a little slide bar where you're like, I'm in the middle with my text, and I slide off as I scroll down. I slide in as I go up. It's a little weird looking like this, but it gets easier. I don't know if anybody wants to read all this stuff. This is basically the routine that does the stack operation to the bottom. So when you scroll down, this throws text onto the bottom stack. And then of course I have the other one. When you scroll up, this throws text onto this top stack. And this is the opposite. If you have a row on the stack that you're gonna throw from the stack to the top, this is really just a print routine where it just prints on the display what's in the stack. The other one, this is scary. This one does exactly the opposite, but the difference is you've got 32 characters wide of data. The Microworks, they let you have any size line that you want. So what it does is it goes through that line, figures out where that first line starts, prints that onto the screen, and updates its pointer on the stack. So it's like, okay, I sent this. This is where the new string starts for the next section. It looks complicated, but if you look at it and go through and realize that it's got a 31 character wide screen that it does, because it has a little flag that shows you that the new line starts with a blank 80 on the display. This lets you store as many lines as you want from the screen, but have it one line of text. So if you type in a symbol, load A, and then you make a big long 4-line text of comments, or you have a big long 30-line text of formulas or FCBs or FDBs, this is what lets you store it that way. Go ahead.
These are all documented in your Unravel books?
Yes.
Great.
Yes.
I'll get some.
And since you asked that though, I did put a notepad in the back. Anybody who wants to actually read this, because you like to abuse yourself, I will email the presentation and the outline to the presentation so you can follow. Oh, okay, this is where he's talking about that. Let me see what slide that is, and you can actually piece it together. But not doing a plug, but actually just talking about it. Yeah, I've got divided up into text where I discuss what goes on, and then I actually have 100% documented code. So you don't have to worry about having somebody explain it to you. You can actually just say, okay, well, that's located here. Let me go read that, and it's explained as you read the code. So
It really is that easy, huh?
yeah. And I shamelessly stole this so everybody would understand. It's like, okay, that's what that book is. He's actually going through the code of the original software and explaining how it works and commenting all the code. But yeah, this one is kind of like, it's almost like it's meant to be a joke slide, because it's very complicated if you've got a lot of capabilities when you're trying to feed back from the bottom of the screen. If you don't care about the width, if you just say, I'm going to be 32 bytes wide, it's nothing. It's not even going to be close to this stuff. It's very simple. And in memory, you've got a certain amount of memory that is going to be available for free RAM use. And when you start off, you've got the CoCo text screen, and you'll have the area for your top row stack and your bottom row stack. So the part where you scroll off and the part where you scroll off, top to bottom, you'll have a space for those things. The way that the Microworks does it, which is the way that I would have done it, anybody else should be doing it. Like I know Dale Lear made one. When you push and pull, you're really going to one continuous segment of memory, just in different locations. So as you start working your way down, you'll be working your way up. This empty space keeps going up and down, and that would be your free RAM, which is right there. So until those two meet, you've still got space that you can do your editing. So all of this, plus what's on your screen, that's your total space for text editing. That's a little complicated, but I hope that made sense.
Do you predefine that? Like, I got this much space for storing text?
Actually, on the slide here, I show there's a pointer at 1B00, and that shows where this is at. There's a pointer at 1B02, and that shows where this is at. 1B0A here, and 1B04. So during the editing process, like they'll display up on the screen how much free memory you have. It does that by subtracting these two and saying there's how much free memory you have. If you look at this value and you see it matches this value, you know that stack is completely gone. Same thing down here. If those two match, you know that stack is completely gone. So using those 4 pointers, you can look at that and see where you are, how much space you have left, how much space you have left in each one of the stacks. So you can see how much is available for doing future editing or scrolling to the next items that are on the screen. But when I did the disassembly, this was hard to figure out. So I can understand that if nobody's ever done this, this would be very confusing. But after you work with it for a while, if you're doing this kind of software or you're using this as an application for something where you're saying, well, I just want to record values and I'm going to make a table, but I want to be able to see my table of values. It doesn't have to be for full screen editing. This could be for anything. You know, if you wanted to make a debugger and it's like, okay, well, I wanted to keep track of every time I did an address call. You know, this would be a great way to do it too. So you could scroll up and down, see all the values, but not have to worry about, okay, well, where am I going to store all this stuff? Well, just make yourself that kind of stack and read it in and read it out by scrolling through the data. And this is kind of almost just for fun. If you have a 32K CoCo, you probably have 16K available for RAM. And the number of rows you can get would be dividing the amount of memory by 32 because you got 32 bytes. And so 16K divided by 32 bytes. Doing it this way, you would only have 512 possible rows of text. And that's where going into the text editor part of the editor, you have to find a way to save memory. This is what you would see on a standard thing. And this is actually the routines that I was showing earlier. If they were on the screen, you can see where all the text blocks out to. And the thing that's going to let you save memory is this is the only stuff you care about. All this stuff that's in black, you don't want to save that. It's just spaces. So when you save these, save them as strings instead of a complete line of text. So this one here saves screen up, EQU, asterisk, and at the end, store a 0 terminator. So this becomes a string rather than saving an entire row of text. That way, all of that stuff that's on there that you don't need to save, let's see what I have on here. Total, yeah, so I would use 333 bytes, but now I only need 179 because I don't save the blank spaces that are on the screen. They make a huge difference when it comes to what do I want to use my memory for.
You're saving the spaces within the string, but not.
Yeah. So when I recreate this, since I know that that's blank spaces out there, I just print up to here, and then I just print blank spaces after that, and I recreate exactly the same thing.
And when you hit the delimiter, you're done.
Yeah. And when you look at the way they wrote their code, there's a few places where you get kind of confused and it's like, what the heck are they doing? And you realize, okay, they counted out how long this line is, and then they went back and printed the string at that length because they know that's how many bytes that string's going to use. And it's like, okay, like I said, there's some things that you're like, what are you doing? And really the whole thing is, I go from the right side or the left side to the right side, and when I hit the terminator, everything after that is spaces. If I've got two places where I've got like a 0, let's say this one was also a blank line, this would be a 0, this would be a 0, I would do a blank line, skip down, I hit another 0, do a blank line. So there I had 2 bytes that took the place of 64 bytes worth of data. So it's a way of, it's almost like compression, you know. How do I save memory? And this is the same thing without the data on there, so you could see This is actually what's required. The yellow squares plus the zeros. That's what would be necessary to store on the stack when you're doing your scrolling. Nope.
I did, but I'm gonna hold it.
Oh, go ahead.
So that's probably enough. If you needed more, you could probably go and check that.
Yeah. One of the things that this does is this says, okay, everything that's in there, it's going character by character. But what I would like to be able to do is say, okay, I want to save more memory. If I wanted to, like if I'm doing a assembler characters, I could say, okay, well, load A is now, let's say $32. That would tell me, okay, this is going to be a load A text, and that would take me from 3 characters down to 2 characters, and I could save more. So definitely anything that would let you save memory, I would use. On a Coco 3, I'm not going to worry about it as much because I got more memory, and if I've gotten more efficient doing it this way, I'm going to be okay on a Coco 3. But that's something that I want to do next because this was made without a Coco 3. They didn't exist when they put this together. So yeah, any kind of, like you said, tokenizing, if there was like a lookup table for, anytime somebody says return, if I want to make a dictionary someplace and it says, okay, here's a way of encoding commonly used words, that would be a good compression method. And the only thing it has to do is it has to be able to figure out how wide of a space do I need for that so I can store it, and also when I restore it, how wide do I need, and then print out the blanks. Because
I was just going to ask, if you're restoring a string, you take 32 minus the length of the string and print that many spaces past it to,
right,
in case there's text there, you'll blank it out.
right, yeah, because I know some places they'll do it where they'll just put in spaces until they get to the last byte of the string or the row, because you'll have a 1F at the end. Yeah, and then some places they'll say, okay, well, I'm pulling back, so I'll go ahead and do the math so I can find out how much I can print here, and I'll leave the rest. And it's, like I said, it's case by case as to how they need it in the software. So, if they need to pre-calc, they do the math. If they don't, they print out, and then they space until they get to the 1FF, or 1F at the end of the row. Whew. Yeah, this is the deep dive part. They use, and this is one of the things I don't like, they use Coco screen characters in the memory. When they write out to a file, they use ASCII, and they pretend like bit 7 doesn't exist. So for this, they don't have that. But I agree, you should be able to say, okay, I'm just going to use the high order bit to be the end. That way you save a whole byte. Yeah. So that's a good way to do it. And in the assembler course tomorrow, I'm going to break down how they do their symbol storage. And for them, they actually use the bit 7 on all the symbol characters to flag for different things. Has it been stored? Has it been defined? Is there a link for cross-referencing for the symbols? But for some reason on the editor, they don't do that. And my theory is, I think that Microworks, they had other things that they were doing. And they had the assembler, which is what I got into, but they also had Forth, and I think they had another thing that they were doing. And this was their genetic editor for all of them. And rather than get into defining those, they just said, let's define characters by what the Coco screen has, and let's save by ASCII. And they didn't bother with messing with the 7th bit, which would have saved money, memory, and given you more storage capabilities. So yeah, I agree with you. Okay. Okay, requirements for extended screen. Was this even necessary? Let's see. Okay, I see what I'm saying here. If you're going to do this where you're scrolling off and everything, the requirements would be that you know the cursor position, the cursor controls that are being executed. I'm going to lean out and read this like I shouldn't do. Which ones are being maintained, have an algorithm of how the screen is manipulated, and all the other operations that are being accomplished. And some of this, if you were to look at the book, you would see things like, I'm scrolling and I'm also going to be saving a block of text. So I have an algorithm for how to save this block of text. So I'm going to scroll, but I know that I have to offset by however many rows that block of text is that I'm saving. So that's where I talk about algorithms. And if you talk about jumping screens or paging screens, then you have to know, okay, I'm going to page a screen. How many rows am I paging by? Because the paging is really just print 16 lines of screen to the stacks and pull 16 lines of screen to the stacks. Now you've paged up to the other screen. So those are the kind of algorithms and mathematical formulas. So you can say the cursor position is the same position, but the screen is moved. Or the screen is moved, but the cursor position has also moved. Where are we located at? And the only way you're going to know that is, what are you doing? You know, are you paging, scrolling? Are you shifting all the data on the row? Because some of the things they do is insert and delete text. So if you insert text, you'll actually insert bytes onto that. It'll scroll down and it'll move the screen lower. So not trying to make it more muddy, but if you're gonna be controlling the screen and controlling the cursor, you gotta make sure that they stay in alignment. And that's really all I'm trying to say on that one slide there. And I'm sorry if that went through everybody. Let's see. Yeah, the stuff I don't cover in this presentation, we were talking about ASCII and CoCo screen. That would be from the disk access and converting the characters, operations of lines longer than 32 characters. That was that one big one where you had all that code, so you could break it out if it was longer than 32 characters. Calculating RAM, I didn't talk in any detail about how to figure out how much free RAM you have, but I do have the information in the book, and they do have use of wildcards for searching. So if you say I want to find something, you can go in and find it with a search. Like I talked about, extending and deleting text, inserting text, exchanging text. There's a lot of different things that the editor has that I can talk about if you guys want to talk about it individually or in the question period, because they do make sure that it essentially acts like a word processor. So anything that you normally would do with Word or something like that, they want to try to emulate it in this. And that's about it. So hopefully I didn't just run past everybody on all that. Has anybody got any questions or anybody want to open up discussion on a certain kind of process there? Yeah, I think I just blew past everybody. Yes.
I find it fascinating.
Inserting and deleting text.
What's that?
My question earlier was about inserting and deleting text, because it sounds like to save memory, right? I'm not going to store this whole line. I'm going to store the string of the line that I want, right?
Right.
So when I go to insert a character into that line, now I have to, how do I allocate the memory?
Yeah, and that
The string was 15 characters, now it's going to be 16.
that's what they'll do here. Like if you're saying, okay, I've got something on my screen and I start typing, they'll go ahead and take the bottom row of the screen. When you get to where that row needs to scroll because you've been typing, it'll store it down here and just keep on going. So you can keep growing by using more and more of the text screen, and it dumps it into the bottom stack so that you really don't have to worry about it. As long as it keeps dumping the bottom of the screen, down into that bottom stack, you've still stored all of the text information that was on the screen that scrolled off. And as you keep typing, you're now doing the opposite, I should say. When you get to the bottom of the screen, you're going to keep typing and it's going to scroll up and off. So everything that was above what you're typing winds up going to the top of the stack.
I'm talking about where the data is stored. So like if you, let's say you have just one line that has 8 characters on it,
Mm-hmm.
and you add one to it.
Yeah.
Well, what's going to happen to the characters that come after that string?
Yeah.
You have
Well,
to, like, reallocate all that memory?
no, that's where, like, if you scroll off, as long as you don't use that entire line, because we're saving space at the end by blanking out any spaces.
Okay.
Once you go past that in line, that's when the scrolling happens, and the bottom line goes off into the stack. And if you're typing and you go down, and you get to that edge and you type off, and it gives you a new blank line, then the top line goes into the stack. So if you've been typing 15, 16 lines, it's constantly feeding that up into the stack because you've already started scrolling the top of it off into the top stack. I'm sorry, you were asking something?
I was just gonna ask, booths 30 and 31, where are they roughly in the room?
What's that?
Where in the room
Oh,
are your tables?
If you go back around the far side of the room, through the back double doors, right there. We're easy to find because we're the only one who have a big table full of honey. So, yeah, no, it's not a euphemism. I'm a beekeeper, and my wife is selling honey, and then I've got some Cocoa 3s I'm selling, and then I've got all of this stuff, and I've got some books that I really like that I brought with me if anybody wants to buy some of them. No, they're full of bites. But yeah, this is a little dry because it's all about file management and data management and saving information. There's no real exciting, fun laser blast or sprites or anything in this. But like I said, if you're looking for something that lets you save data, scroll it off. Like I said, if you're just looking to save numbers, this is actually applicable. It's just instead of a screen, now you've got a list of data, or it could be bytes, it could be floating point numbers or whatever. So, you might be able to find some way to use this if it's not something that you're looking for a full screen editor.
I got a stupid question. You're showing the stack there.
Mm-hmm.
Is each part of that stack just one byte and it's a pointer to where it's storing the string?
No, I just kind of represented that like one full line of text. But when you actually start storing strings, it would be variable width. So it's like, let me just do blocks.
Each portion of the stack is part of the string.
Yeah. This is all data. It'll have the characters, the null.
The other was saying, well, how are we saving space? We're just having an interaction. Okay.
Yeah, because.
I told you it was a stupid question.
Oh no, it's like that thing. It's like there's no stupid questions because when I first started looking at this, I was like, well, why are they saving null terminators in different places that I didn't understand? And it's like, oh, well, we're marking out. This is the 32-bit or 32-bit or 32-byte space, but we're still going with characters. The null occurs at the end of the entire line, whether it's 120 bytes or 10 bytes. That's where the null goes. Because I was assuming, oh, there's going to be something like at the end of each line. No, it's at the end of the entire line of text that you're editing. So it adds a twist, but it gives it more capability. Yeah, that's where it goes around. Gosh, I almost want to fire it up. It goes around to the end, and if you're still doing a continuous line, that's where it'll do the 8-0 on the screen for the next byte, and it'll leave a big black chunk there. And then you keep on typing, So when it goes to send that off to the stack, it reads it through and it looks down, it sees a 80 at the next line, and it says, oh, ignore that, just keep sending text. And goes down, sees another 80, just keep sending text. And when it gets to where there's a spaces at the end and it doesn't see one down there, it'll zip back and say, to this point, all this data goes off to the stack, and then put a null terminator. So it stores only what's necessary for whatever line you're typing, if you consider a line being a line of code as opposed to a line of text. If that makes sense.
Do you need a line terminator as well as a screen?
Yeah, it uses one terminator for a line. And the line is either going to be a line shorter than 32, which is where you see those characters going out there, or it's going to be more than a line that's 32, but when it reads in onto the screen, it'll keep trimming off anything that's going longer than the 32, making it shorter and shorter and shorter until only the line that's less than 32 comes out, gets stored on the screen. And then it behaves like one of the other ones where it's like, okay, I've got that one, except it's going to have the black square at the beginning, and then it's going to null off at the end and do spaces. So the way that they present more than 32 lines of characters is by using that black square. And they will introduce it when they scroll down, and they will introduce it when they scroll up, because it's one line of text rather than one row of text. And like I said, I've done a lot of them where I'm sitting there typing when you got 32 bits or 32 bytes wide, and I do a 6-character label, 1-character space, 5-character opcode, 1-character space, and then 10 characters for a opera hand, and then you put code or you put comments after that. You're going way past the 32-bit barrier, and that's what they provide you that ability with. Is that exciting or what? But yeah, if you guys are interested, like I said, I've got this slideshow, and I've got an outline on the slideshow, so you can look at the outline and say, oh, here's what he's talking about, and then you can look at the slides and say, okay, that's the answer I was looking for, and I can email that to you guys if you put your email address back there, and just make sure it's legible, so I'm not sitting there going, is that Foggy Bottom car? He's not getting an email. But yeah, tomorrow, if you're into the assembly stuff, it's going to be all assembler, and it's how does the assembler take a file of text and convert it into binary code. And it's not as easy as this one. What's that? Oh, well, I will tell you, I originally disassembled this by hand, and then I went back and I assembled it using the Microworks assembler because that's what I was working on. And I got the editor, no problem. I had to break it up into something like 20 separate files so I could include files. But when I did the assembler, I broke the Microworks assembler. It couldn't handle the number of symbols it required. So I had to go back to LWSASM. Yeah, it could not assemble itself. So I used LWASM for the assembler, and when I did that, I was like, I'm just going to use this for both of them, and when I get done, my goal is to eventually have a version of this that can assemble itself. But yeah, I would assemble on a real CoCo. I was assembling the editor, the thing that I was talking about today, and it would take 15 minutes just scrolling and scrolling and scrolling. And I did LWASM the first time, and it said assemble, enter, and I'm like, it didn't do anything. And I was like, oh wait, there's a list file. And it was done. So I appreciate that. One of my goals though is to make a CoCo resident editor assembler IDE, and the big reason why I actually started on this is I want to be able to add it, the ability to do 6309, because there's none of that in there right now, and there's nobody that's got anything made to take advantage of the powers that are in the CoCo 3. So I could do this stuff where I can page memory, I can store files that would be like RAM files. So during assembly, I could say, okay, well, this file is stored, and I'll just go ahead and reassemble from the stored file. And I don't know if I want to keep doing this to myself, but I think I've realized my problem. I just don't know how to stop.
Oh, no, you just stop
Yeah,
it.
I can stop tomorrow. I can.
You can stop anytime.
Yeah. But yeah, if you guys want to come by the table, go through any of the code with me, ask questions, please come on down and join me in my nerddom. But I guess that's it for this streaming. Please take me off the air.
Can you go down to the last slide where you show your email address?
Oops. Oh no, what did I do?